everyone, this is Module 5, Lesson 5, Chance Experiments with Outcomes that are not equally likely. Okay, so basically we were talking about if you spin a spinner and all the sections are the same size, or you roll a dice and all the sides have an equally likely chance of happening, or flipping a coin, it's equally likely that you would get heads or tails. So we're going to talk today about some chance experiments. So that's, things that have already happened or using data. Okay, we're going to use that, and it's going to be probabilities that are not equally likely. Okay, so down here below in example 1, when Jenna goes to the farmer's market, she usually buys bananas. The number of bananas she might buy and their probabilities are shown in the table. What is the probability that she will buy exactly 3? So underline that, exactly 3. So it says that there's a 0.2, which you know is 2/10, also known as 1/5 if we reduce it. And that's 20%. It's just good to see all those different formats so that you know that those are all the same. So there's a 20% or 1/5 chance that she will buy 3 bananas. And you can leave it at 0.2. All those things are the same. Okay, what is the probability that she does not buy any bananas? Write that down. What is the probability that she does not buy any? Okay, did you get 0.1? Which is 1/10, and that is already reduced, and that's 10%, because right there, that's when she doesn't buy any. Okay, how about if she buys more than 3? More than 3. More than 3. That doesn't include 3. Okay, that would be these two. So you can write that as 0.2 plus 0.3. You can write it as 2/10 plus 3/10. No matter which way you write it, you're going to get 5/10 or 1/2, which is the same as 0.5. Okay, when you add those together, it's 0.5, and you know that that's 50%. Okay, so there's a 50% chance that she will buy more than 3. Okay, try this one on your own. What is the probability that she will buy at least 3? And my hint to you is at least 3 means that it's okay if she gets 3. It means 3 or more. Okay, so you can do 0.2 plus 0.2 plus 0.3. And that would be 0.7. 0.7, which is 7/10, which is 70%. Okay, what about the probability that she doesn't buy exactly 3? Doesn't buy exactly 3. So anything except for 3. Anything except for 3. So basically we're taking that one out. Well, there's two ways you can do it. You can do it the long way, which is to add up all the probabilities. So she's either going to buy no bananas, 1 banana, 2 bananas, 4 bananas, remember we're not including 3, or 5 bananas. And you can add all those up. And if you add all those up, you get 0.5, 0.6, 0.7, 0.8. Did you get 0.8? There's a much quicker way, because what you can do is if there's a 0.2 chance that she will buy 3 bananas, you can just subtract that from 1 whole. 1.0 minus 0.2 is also 0.8, which is 80%, or 8/10. And that's 4/5 reduced. Okay, hopefully that makes sense, because if there's a 0.2%, or sorry, a 0.2 or 20% chance that she will buy 3 bananas, then there's an 80% chance that she will buy something other than 3 bananas. Okay, notice, and with that comes the answer to letter F. Notice that the sum of the probabilities in the table is, what if we added all those up? We would get 1.0, which is equal to 100%. So that makes sense. That's 1 whole. Okay, now we're going to talk about Jenna's husband, Rick. He's been trying to eat some more fruits and vegetables. So here it says that on any given day, he eats 0 servings, 1 serving, 2 serving, 3 servings, or 4 servings of fruits and vegetables. So the probability that he would eat no servings is 0.08. So sometimes he does it, but doesn't look like that happens very often. And then so on and so forth. The chance that he would eat 1 serving is 0.13. The probability that he would eat 2 servings is 0.28. For 3 servings, the probability is 0.39. And for 4 servings, the probability is 0.12. Okay, you are going to pause and try all of these on your own. Okay, so it's very similar. It's very similar to the page with Jenna and the bananas, except this time we're just talking about fruits and vegetables. Okay, so you give yourself a few minutes to do this, maybe 3 or 4 minutes, and then when you're all done, make sure you've used pencil, and I will put the answers up. Okay, good luck. Okay, did you pause it? Only you know if you actually tried it. Okay, let's go ahead and see how you did. Okay, 2 servings, 2 servings. That one was easy. That was just right here, 0.28. Now, if you want to write it as a fraction, go for it. That's 28 over 100, because 28 hundredths are 28%. You can reduce it, and then you can actually reduce it one more time. Okay, how about more than 2? Did you get 0.39 plus 0.12 is 0.51, which is a 51% chance? And then at least 2 means 2 or more. At least 2 means 2 or more. So did you add up 0.28 plus 0.39 plus 0.12? Hopefully you got 0.79, which is a 79% chance. Underline those phrases, at least 2 servings, more than 2 servings, and this one was exactly 2 servings. Okay, what's the probability that he does not eat 2 servings? So that would be everything except for 0.28. I really think the easier way here is to subtract 0.28 from 1 or take 28% away from 100%. Maybe that one makes more sense. And that would leave you with 72%. There's a 72% chance. I bet some of you actually got that by doing it the long way, by doing 0.08 plus 0.13 plus 0.39 plus 0.12. And guess what? That does work out to be 0.72. Okay, but to me, this way is quicker. Or this is equal to 0.72 as well. Okay, all right, let's go on to some examples with fractions. Example 2, Luis works in an office and the phone rings occasionally. The possible number of phone calls he receives in an afternoon and their probabilities are given in the table below. Okay, let's find the probability that he receives 3 or 4 phone calls. Okay, it's not separate, it's telling you to put those together. Like, what's the probability that he would receive 3 or 4, which is on the high end? All you do is 1/3 plus 1/9. And if you remember with adding fractions, you need common denominators. So instead of 1/3, we need to write that as 3/9. Now we can add, whoops, sorry, that was supposed to be a plus sign. Now we can add 1/9. Okay, so 1/9 stayed the same. 1/3, though, has to be written as 3/9 because those are equivalent fractions. And now I add the numerators, and there's a 4/9 chance, which is almost half. Okay, what's the probability that he receives fewer than 2 phone calls? Fewer than 2 would be less than 2. Okay, so if he receives 0 or 1 phone call, that is a 1/6 chance plus 1/6. I love when I see that the denominators are the same because I just add 1 plus 1 and leave the denominator, which is 2/6, and we know that that reduces to 1/3. Again, this is a common percent. It's really good to see this. 33 and 1/3% can also be written as 33.3 repeating percent, but it's just good to see that the more often you see it, the more comfortable you'll be with it. Okay, what about 2 or fewer? What about 2 or fewer? Let's clean this up so we can see our chart a little better. 2 or fewer would include 2. So I have all of these. Oh man, I'm seeing some different denominators there. 1/6 plus 1/6 plus 2/9. Okay, there's two ways you can do this. You can make the denominators all out of 18 or even 54. But with math, I'm going to see if I can make it a little simpler. I'm going to add the 1/6 and the 1/6, which is 2/6, which is 1/3. And now I'm going to add 1/9 to that. The reason I like that is because I'm going to actually draw an arrow so you know the 1/6 plus 1/6 was right here. And then I just carried the 2/9 over. Okay, so 1/3 plus 2/9 is equal to 3/9. Remember 1/3, we already changed that earlier. So 3/9 plus 2/9. And that's 5/9. Now, there are other ways to do it. You could change them all to have a denominator of 18 and then add them together. And then you would have to reduce just a little bit. Not too bad. In fact, I'm going to do that for you below so that you can see, and we can write it right here. So 1/6 is 3/18, 1/6 is 3/18, and 2/9 is 4/18. Okay, remember whatever you do to the bottom number, you have to do to the top. And if I add 3 plus 3 plus 4, I get 10/18, which is equal to 5/9. Okay, so actually I'm not sure which one was quicker, but at least that way you can see two ways to get the same answer. Okay, now the last one, the probability that he does not receive 4 phone calls. Does not receive 4 phone calls. So that would be everything here. But think about this. Think about this. Not 1/9. What's everything except for 1/9? Like, what would be left if you took 1/9 of a pizza away, or you got 1 out of 9 problems wrong? What would be everything else? It would be 8/9. So there's an 8/9 chance. Okay, and again, the other way of looking at that is 1 minus 1/9, or all of them 9/9 minus 1/9. It's a lot quicker to look at the complement. That's called the complement. Okay, go ahead and try exercise 3 on your own. It's very similar to what we just did up above in example 2. Okay, go ahead and try this. Okay, exactly 3 would be right here. That's it, 1/4. Okay, how about if she does not buy exactly 3? Okay, so that would be like not 1/4. Just like what we talked about above. So that would be everything else. You could spend your time adding together all the ones except for 1/4, but really we know that that's the other 3/4, or the complement to 25%, the other 75%. Okay, how about more than 1? More than 1. So that would be all of these. And that one's not too bad because 5/12 plus 1/4, 1/4 is the same as 3/12. And then 1/12. So really the only one I had to change was the 1/4. Okay, 5 plus 3 is 8, 8 plus 1 is 9, and 9/12 is 3/4. So there's also a 3/4 chance that I would buy more than 1 head of broccoli. Okay, what about at least 3? How did you do on that one? At least 3. By the way, if you're struggling with the fractions, you might want to ask me in class, say, can I have some practice, or can you help me with adding fractions? I kind of forgot how to do that. Okay, so at least 3 would be 1/4 plus 1/12, which we know that 1/4 is actually the same as 3/12, and now I can add them together. I get 4/12, which now we need to reduce that one to be 1/3. There's a 1/3 chance. Again, if that was going a little too fast, you might need help with adding fractions. Okay, the last page 38 is with a clock, and I want you to go ahead and do number 4 all by yourself. Pause it and try those. It's not too bad. It's like a clock, so I'll give you a hint. The denominator is 12. Denominator is 12. Okay, good luck. Okay, for red, did you get 1/12? For blue, did you get 2/12? For green, did you get 5/12? And for yellow, did you get 4/12? The other way that you can check this is all your numerators, 1 plus 2 plus 5 plus 4. What should that equal? It should equal 12. 1 plus 2 is 3, 3 plus 5 is 8, and 8 plus 4 is 12. So therefore, I know that it's one whole all the way around all the segments. Okay, and then don't forget to write these in lowest common terms. Okay, so now for the table, we're just going to quickly fill in. Red has a 1/12 chance. Blue has a 1/6 chance. Green has a 5/12 chance. And yellow has a 1/3 chance. Okay, what's the probability that the pointer will stop in either the blue or the green? Blue or green. You can go back up to the clock and count them together. 1, 2, 3, 4, 5, 6, 7. So that would be 7 out of 12. Or you could do 1/6 plus 5/12, which is 2/12 plus 5/12, which is 7/12. And then what's the probability that it does not stop in green? Well, if green is 5/12, all the other pieces together would be 7/12. So it's a 7/12 chance. Okay, go ahead and do your summary, and that is a wrap on lesson 5.